So we are moving on to equations as functions. So just to kind of reiterate, we have already, what you already know is that we have these things called relations. And they can be shown as ordered pairs. They can be shown as mapping. They can be shown as graphs. And they can be shown in a table. Okay, these relations are functions when there are no repeating x values, meaning that one input per output. So one input per output. All right. Now, we have not talked about equations as functions. So we're going to talk about now equations. So functions can be represented by an equation or a rule. And basically this is kind of what we talk about. You just need to follow the rules. When you're in math, you have to follow the rules and just be a rule follower and everything will go much easier for you. The equation that will generate an ordered pair, meaning that when you have an x value, you will get a y value. So you'll get an ordered pair by taking the input, which is your x, you plug that into the equation, and then you're going to get an output, which is your y. All right? And so here it shows you kind of like a machine. If you says, think of a function like a machine that takes an x value or an input, something you put inside the machine, the function kind of messes around with it, and it produces a output. So if you think of the ingredients go in, the function mixes it up, and then out comes your cookie or whatever. So when we're up here, the graph of an equation is the set of its ordered pairs, which often forms a line or a curve or some sort of graph. Okay, now your x term or value is called the independent variable. And that is because you choose that first. This is again your input. What ingredients am I going to put in? Then the y value is called your dependent, because depending on what dependent? Because depending on what you put in, that will determine what you get out. So this is your output, right? If I put cookie ingredients in and I do the recipe correctly, then out comes a cookie. If I put cake ingredients in, then this does this thing, and then out comes a cake. So depending on what I put in, out comes whatever. All right, I must be hungry because I'm using all these food examples. All right, moving on. So graphing functions with an equation. So if I look at this equation, I'm going to say, okay, I'm going to, this remember is my input. When I put in -5 into this equation, what is my output? Well, when I put in -5 into the x place, -5 plus 4 would give me an output of -1. Are you with me? And you may know how to do this, but it is important to understand what is actually going on. You may just think, oh, I know how to do this, it's common sense. But you really do need to understand Okay, so -4, when I put my input of -4 into the x, -4 plus 4 is going to give me an output of 0. When I put my input of -2 into the x, I would have an output of +2. And when I put an input of 0 as my x, my output would be 4. So when I graph these points, -1, 2, 3, 4, 5, -1, then -4, 0, -2, 2, -0, 4, 1, 2, 3, 4. This is what those ordered pairs look like, okay? But the big, huge difference between an equation and ordered pairs is that in an equation, this rule goes for any number that I plug in. So I could get in here and do all these little decimals. Every single number in between -5 and -4 is also going to give me an output, and those are going to basically be represented because a line is really just a bunch of teeny tiny little points, ordered pairs that are so close together that they look like a solid line. It's not really a solid line. It really is a bunch of teeny tiny little ordered pairs all represented by this line, and it goes on and on and on forever. And there's no limit to what x value you can put in, okay? All right, so that's why in my domain in this situation would be -infinity to +infinity, and my range would also be -infinity to +infinity. Okay, so keep in mind, we're still talking about domain and range even when we're not talking about it because it's important. So there you go. Now, number 2, we've got this equation and we've got a table. These again are my inputs and I'm looking for my outputs. So when I put in -4 into the x, -4 times 3/4, well, I might need to 3/4, and then instead of x, I'm putting -4 minus 2, 3/4 times -4, well, my 4's are going to cancel out, and I'm going to get y equals -3 minus 2, which of course then gives me -5. Okay? Again, if I put 0, y equals 3/4 times 0 minus 2, well, anything times 0 is going to give me 0, so y would equal -2. Y equals 3/4 times +4, that's going to give me 1 because the 4 divided by 4 is going to cancel out, and I'm going to get 3 minus 2. And y equals 3/4 times 8 minus 2. Well, I can multiply these and get 24 divided by 4 and divide and get 6. Or I can say 4 divides into 8 2 times. And since it's an even division, that makes my life easier. And so then I get 3 times 2 is 6 minus 2, which y would equal 4. I don't know if you guys are learning how to do these simplification of fractions. I hope you did. I hope you learned that. If you didn't and you want more practice on that, let me know. All right, so now when I plot my graphs, I'm going to go to -4 and -5 and plot that point right there. 0, -2, 4, 1, and 8, 4, which would be way off the graph, which I'm not going to worry about. So this is going to form this line because it's an equation. If it was just the table, I would only have those points. But since it's an equation, I can connect the points. And I should have written that over here. Connect the points. Whereas the ordered pairs do not connect. Do not connect. Do not connect. If it's just ordered pairs. All right. Now, and if you have questions about that, please bring it up. So then here we've got this situation, y equals 3x. So if I plug in -2 in for my input, y equals 3 times -2, that's going to give me -6. Y equals 3 times -1, that's going to give me -3. Y equals 3 times 0, that's going to give me 0. Y equals 3 times 1, that's going to give me +3. So when I go to graph this, -2, 1, 2, 3, 4, 5, 6. -1, 1, 2, 3. 0, 0, so this is going through the origin, and 1, 3. Since it's an equation, I'm going to connect my dots because I know that the equation means that all of the points in between those ordered pairs are also included. All right. And now we've got this last one. Hopefully you're getting it. If you want to pause the video and check your answer, I would suggest you do so now. All right, so then this is my input, my output, and I'm going to get 3 plus 2 is 5. This would give me 2. This would give me -1. And this would give me -4. So if you don't know how to get that, stop the video, work these problems out, and make sure you know how to get those answers. So -2, 1, 2, 3, 4, 5, 0, 2, 2, -1, and 1, 2, 3, 4, 1, 2, 3, 4. Now let me tell you, if you're plotting these points and they are not forming a perfect line like these ones are, then there is a problem. Houston, we've got a problem. So make sure that your points are forming a beautiful line. Moving on, there's a couple more. So we've got this one. If I were you, I would stop the video, make sure that you can do these because we're getting to the end, and if you are confused or needing to struggle through this a little bit, I would highly recommend you do that. That will really benefit your learning. So we've got x is -3. Well, I've got this. So this is actually y equals negative plus 1. I'm going to plug in whatever the x value is here. So in this situation, I'm going to plug in -3. Well, a -3 is actually a positive, right? -1 times -3 is going to give me +3. Plus 1 is going to give me +4. Then when I plug in the next one, -1 is going to give me a +1, which is going to give me y equals 2. Negative, I'm going to put 0 in. And of course, -0 is just 0, so I get 1 there. And y equals negative and then +4. So this would actually become a -4 plus 1, which is -3. And again, I'm going to double check and make sure this is forming a beautiful, lovely line. So let's see, -1, 2, 0, 1. And then 1, 2, 3, 4, 1, 2, 3. And will that work? You betcha. When I put my ruler on, you can just see that all the dots just fall right in line. So, and for the very last one, here we've got y equals 1 minus 1/3, and then I'm going to put the x there. So whatever my x is, I'm going to put -3 there. 1 minus 1/3 times -3. Well, -1/3 times -3 is going to give me +1. So that's going to give me 1 plus 1, which is 2. 1 minus 1/3 times 0, well, that's going to be 0, so y would equal 1. And again, if I'm going too fast, stop the video, make sure you can do this math, and then start it back up again. Stop the video. Be honest with yourself. Then if I've got this 1 minus 1/3 times x, 3 is plugged in for x, I'm going to get 1 minus 1, which is 0. And then the very last one, y equals 1 minus, and I'll write that one down, y equals 1 minus 1/3 times, and then instead of x, I'm going to put 6. So when I multiply this out, 1 minus, I would get 6 divided by 3, right? 1 minus 6 divided by 3 is 2, which is -1. All right? Please make sure you can do those. You may not be able to do those as fast as I did, but you should be able to do them at least in your head a little bit. 0, 1, 3, 0, and 6. So that's 4. So 1, 2, 3, 4, 5, 6, and -1. And once again, when I put my ruler up to them, that forms a beautiful line. I'm not trying to finagle anything. I'm just connecting them all. All right, moving on. So given each function and domain, find the range. So basically all it's asking you is to plug in this domain. So they're saying these are my x values. Given these x values, what would y equal? And if you want, go ahead and create a table and just put in, I've got 4, 6, and 8. So when x is 4, y is going to be -1. When y is 6, or I'm sorry, when x is 6, 6 minus 5, y would be +1. And do you see, I'm just plugging these x values in for the x in this equation. Then when x is 8, I'm going to get y equals 8 minus 5. And that would equal 8 minus 5 is 3. So my range, let's write that in a different color. So my range is -1, 1, and 3. All right, are you with me? Moving on. So we've got this other situation right here. We've got our domain, which are x values. This time we've got 4 given inputs. We've got -1, 0, 1, and 4. All right. So when I plug each one of them in, y equals 3. I'm going to put my input in that box, these different values, and then figure out what y would be. So y equals 3 times -1 plus 1. Well, 3 times -1 is -3, plus 1 is going to be -2. Y equals 3 times 0 plus 1. Remember, I'm just taking this entire equation and I'm just putting, the only thing that's changing is what is going into the x value. 3 times 0 is 0, plus 1 is 1. Y equals 3 times 1 plus 1. 3 plus 1 is 4. And then my last domain of 4 is going to give me 12 plus 1, which is 13. So in this situation, my range is going to be -2, 1, 4, and 13. Those are my range. All right, see if you can maybe do, now they get a little bit harder here, in here with the fractions. But see if you can do 8 and 9, and we'll check our answers. So pause the. All right, so hopefully you paused the video. If you didn't, then go ahead and pause it now and just make sure that you can get these answers. So here my range is -1, 1, and 6. And here my range is -4, 2, and 5. Okay, all right, moving on. I'm hoping you're getting this. If not, then you might need to stop. I know you think you want more help from me if you're not getting this, but actually you probably need more help from you to take a moment and just try and think and let it marinate and figure it out. All right, so I'm going to just give you actually the answer here. My range in this situation is going to be when x is -4, y would be 9, because 7 minus 1/2 times -4 is going to give me 7 plus 2, which gives me 9. 7 minus 1/2 times 0 is going to give me 7 plus or minus 0, which will give me 7. And then 7 minus 1/2 times 6 is going to give me 7 minus 3, which is 4. So my domain is going to be 4, 7, and 9. All right. And this situation, your range, I'll just talk this one out with you. When x is -12, that's going to, a negative times a negative is going to become a positive. 12 times 2 is 24, divided by 3 is 8. 8 plus 9 is 17. -6 times -2/3 is going to give me +4, plus 9 is 13. And 3 times -2/3 times 3 is going to give me -2 plus 9 is 7. So my range would be 7, 13, 17. Oops. And for these last two, I'm just going to have you pause the video and get the answer, and I'll show you the answers when I'm done, because the video is getting a little long. And there you go. Okay. So I'd like for you to work this, and this will be your homework. Unit 3, homework 3. That's it for now.